All right, so the fundamental identities are these, right? Can you memorize all them?
Yeah.
Oh, you said no, yeah? It was a yeah, no? Hold on. That's something that is important to remember if you ever take calculus, that the tangent is the slope. It represents slope. All right, so the fundamentals, again, with the Pythagorean is sine squared theta plus cosine squared theta is equal to 1. Tangent squared theta plus 1 is equal to secant squared theta. 1 plus cotangent squared theta is equal to cosecant squared theta. Finding trig function values given one value and the quadrants. So if tangent theta is equal to -5/3 and is in quadrant 2, find each function value. So you just to find secant, right? You plug the -5/3 in, you square it, you add 1 to it, and that's how you get 34/9. And then you take the square root of it. So that's how you get secant of this. Oh, also it's in quadrant 2. Remember the secant is what? The x value? And it's in quadrant 2, so that's why it's negative. Oh yeah. So is there any question about that? Especially with the quadrant thing and how you ended up with negative? So we have sine was using the same number, right? So we're just gonna plug that in. Let's see, what are they? Oh, they're using an identity. Oh, no. They're just using the actual sine over cosine identity, and then they cross multiply cosine on one side, and then they said that the cosine is equal to 1 over secant, right? So it'll be and you got to do some math gymnastics, right? So let me see if I can write on the screen. I'll just join on my iPad. Let's see if it lets me write on the screen. So 1 divided by the square root of 34/3. And then I am going to 3 over the square root of 34 times -5/3. There we go. Those go away. Can you see what I wrote? And then you end up with -5 over negative square root of 34. Okay. It's negative over a negative, so you know that's positive. And then the square root of 34 times the square root of 34. And that's how you end up with this over here. Now, the only thing is, I'm not sure why they wrote it like that. So I'm going to say this part right here, not this. I don't know why they put that equal. They shouldn't have done that. And then I'm thinking that they put that in the wrong spot. Hold on.
What?
They put hold on, let me go back. So they put the sine, like we were looking for sine theta. So that shouldn't be beside it. It should be equal to, right? Yeah, they made a little mistake there. Yeah. It's okay. Yeah, because it should be sine theta. All right, sorry. So yeah, that should be sine theta equals 5 times the square root of 34/34. If you have a question of how I got this, let me know. Huh? You know you gotta holler. Huh? Go ahead. But you should be taking notes for this too. Yeah. I was trying to do after, even though I got interrupted 15 times, was trying to show you how you got 5 times the square root of 34/34. So if you have a question, let me know. Yes, the reciprocal. Yes. And yeah. Okay. Okay. So for cotangent, they want cotangent negative theta. Okay. So we want quadrant 2 for every single one. Okay. So cotangent negative theta, and that is where, we get the, you see cotangent and tangent, they're odd functions. So sine and tangent are odd, cosine is even. And if you can remember those 3, then you can remember all the other 3. Okay. So we have the reciprocal identity, negative angle identity. So we plug in the -5/3, and then you have the negative with the angle, and then of course you just flip it. And so does everybody understand how they got 3/5? You see? Okay. So you just flip it. All right. So the negatives cancel, and then you just flip, do it with the reciprocal, and that's how you get 3/5. All right, caution here, when taking the square root, be sure to choose the sign based on the quadrant of the angle and the function being evaluated. Yeah, that square can be tricky. Okay, so now this is the part that I was telling you that I love in trig. You're just matching one identity and verifying something based on another identity. It's not really like solving equations. You still use algebra rules, but it's quite different. What'd you say? So when you see something, right? Like when you're looking at this, you have to say to yourself, what identity do I know? Right? So it says write cosine in terms of tangent x. Okay. Since secant x is related to both cosine and tangent by identity, start with 1 plus tangent squared x equals secant squared x. Okay. So 1 over 1 plus tangent squared x is the same thing as 1 over secant squared x. Okay. Just let me know if you can see that. Are you able to see that? And you can tell me, because they're not easy to see at first. So what they're trying to get you to see is that 1 over 1 plus tangent squared x is equal to 1 over secant squared x because of this right here. Okay. And then they're showing you that, well, this is actually equal to cosine squared x. Okay. So those two are equal. And then to solve for cosine x, so that's what we were originally trying to do, cosine x, you just take the square root of both sides. So you just take the square root of this side and the square root of this side, and you have plus or minus. So then also you take the square root of of 1, which is 1, and then you have to on the left side, so we do the square root. I'm multiplying over here. Square root of 1 plus tangent squared x over square root of 1 plus tangent squared x. So it's the same thing as rationalizing the denominator, okay? So what it means is that, like, if I have 1 over the square root of 5, we don't like square roots in the denominator. Never, right? So we have to multiply by the same thing. Yeah. Now, does everybody remember why the square root disappears? The exponent. It is. Well, I just want to make sure everybody knows, because most people just, like, when I learned it, I just said, oh, it just magically goes away. It's a half exponent. No, I can show you the explanation. So I can tell you. Okay, so just as a review, right? If I multiply the square root of x times the square root of x is equal to x to the 1/2 power times x to the 1/2 power. And what do we do with exponents when we have the same base? We add them. So 1/2 plus 1/2 is equal to, okay? So that's why when you multiply these two, and we multiply this times this, that's why one of them goes away. Well, what would it be if I did a cube root? Right, what you're saying. If you're saying, like, because it's double, you say it's half. But what do you do when you get to, like, the 125, which I think was 5, right? So you can say you're separating by 3s, but it's really 5 times 5. 5. Yeah. So, I mean, listen, any tricks that you have in your head, you use them. Like, if you're like, I can figure this out differently, go ahead. That's what it's all about. That's what it's all about. I mean, there were some things that I did different in with techniques that I learned. Well, I tell you what, the best way for your brain to think about square roots is think about a square. So just think about a square. Let's say this room was a square. I don't know if it actually is, but a square, right, is, what's the area of the square? It's the side times the side. Yeah, it's the same side. Mm-hmm. So if you're really wanting to like dive in deep with squares, then just think about that the square, right? Like, what is the area of that? That'll be x squared, right? Okay. So how do I undo that? How do I figure out if I know the area, right? So let's say the area is 25, and I say, sorry, the area of a square is 25, right? How can I easily figure out what the measurement is of the sides? I would take the square root. So if you really, you can keep saying half, but you cannot say it's half technically only. But and then if you want to know what, like, if you want to wrap your mind around a cube, well, that's actually something, the only thing I can do in art is draw a cube. Look at this, watch me. The only thing, I already messed up. The only thing artsy that I can do is a cube. It's an ugly cube, but it's a cube, right? A cube is length times width times height, right? So then that translates into things that's real. So if we have a perfect cube, I don't know, who knows where the length and the width and the height is, somewhere in there, right? But we know there's 3 of them. So then we do the cube root to figure out what the measurement is of a cube. If it's a perfect cube, okay? It could be, okay? And then the sign here at the end, it depends on the quadrant of X, and we said quadrant 2. All right, so rewriting an expression in terms of sine and cosine. So this one is a little bit more involved, right? But I like how they began because it makes a little bit more sense. So they start with taking a whatever, identity, and they say, make it in terms of sine and cosine. So you look at 1 plus cotangent squared theta, and you know that cotangent is equal to cosine over sine, right? Cosine is 1 over sine squared theta, okay? So you just look at those, and you say, okay, all right. Then it says you're going to multiply the numerator and the denominator by the LCD. So the LCD would be just like if you had common denominator is what I was trying to say. Okay. So the common denominator is sine squared theta, and it's the only thing that you can probably do other stuff, but what I would do is I would separate the numerator from the denominator. So I would do the first one here first, over here, right? So sine squared theta plus cosine squared theta over sine squared theta. And then as you wait, if you're done, just think about what you can transform what you have. Are y'all taking notes?
Yeah.
All right. And then, so then now if you simplify it, you divide out those sine squared thetas, you end up with sine squared theta plus cosine squared theta, and you know that equals 1. So this is equal to 1. And then I could, if I readjust this, so sine squared theta minus 1 is equal to negative cosecant squared theta. And then they just replace that with this down here, okay? And then they got the reciprocal identity, which is negative secant squared theta. Are you asking me where they came from? Yeah. So this is an identity. Remember, look at the paper I gave you. It's like the 4 pages or whatever. So that's why I said the first couple of identities, it's best to memorize them because you're going to use them a lot. X squared plus y squared equals 1, right? So the only thing is they write it backwards. They put sine squared first, which is so this is the same thing. I could say cosine squared theta plus sine squared theta is equal to 1, okay? It's the same type of concept. And I think when we first started, I did mention that think about the unit circle with X and Y, even though it's a circle.